Let's get started. Well, first of all, I'd like to thank you all for being here. Thank the organization for allowing me to present this talk to you today. And we're going to talk about how to build .NET software with a focus on scalability and performance, basically. I work for Warren. This is what we do there. It is an investment platform, and we will talk about a little bit about Warren also. So, a bit about myself. I am currently my name is Henrique Gasparotto, first of all. I am currently the head of .NET development at Warren Brasil. I'm a computer engineer, technician in informatics, and for a while back then I did devote myself to a little bit of teaching with technical articles, video classes, and things like that. For a while now I haven't done that. Well, first of all, we need to understand the kind of concept we are talking about. So, what is Warren? Does anybody here is familiar with what we do there? Great, great, some hands at least. So, we are an investment platform. We have apps, Android, iOS. We have a web application as well. And we are the new way to invest well. Bit of a bumper sticker, but okay. We have this cool pinkish, kind of pink background, and it's kind of a trademark for us. It is magenta according to our chief designer, so we focus on the user experience a lot as well. So we try to unravel the world of investments to make sure that everyone has access to good products, to good investments that, well, they're mostly not in the banks, and we are trying to change the way people think about their money. We are an advisor robot. We have an investment system that is based on managed portfolios. Basically, we manage your portfolio of investments. You choose your products, you receive a suggestion, and you accept the suggestion, and from this on, everything is automatic. When we talk about legal, we are a broker. We are also a fund manager. We started actually as a fund manager, and later on we did buy a broker to make sure our customers had access to more and more products every single day. We have at this moment about 250 products in our table. And we also have a savings account. It's not available for everyone yet. We are rolling in kind of a safe way, let's put it this way, but we are working on new products every single day also to bring to you, to the customers. So, to summarize, Warren is a full goal-based investment platform. You talk to the advisor robot, you find your investment profile, let's put it this way, you receive a suggestion, personalized based on your goal and your investment profile. You invest, you keep track of your rentability, all in the same place. But how on earth did we build all of this? How the architecture that we built to sustain all of these kinds of investments, different sorts of products and things like that? This is one very big picture thing of what we have as a system. We have 3 clients in the street, one web, one Android, and one iOS. We have an API gateway. This API gateway, it has some of the business rules, basically concerning notifications, concerning the way we interact with the customer before it has a full register, and starts investing. So this API gateway is written in Node.js and has a MongoDB database. And from this point forward here, we have what we call the core, the main investment core, which will be the focus of this presentation. We have 4, soon to be 5 RESTful APIs open to this API gateway. We have one single data repository that receives all of these requests, and also we have one big, huge processing service called investments. We will break this into more details later on. We also talk to external systems. We have a lot of them. We need to talk to Brazilian Central Bank. We need to talk to CVM, which is the sheriff of the financial market in Brazil. We need to talk with all the operations, different operations control systems, we have one for private fixed income, we have one for variable income, we have one for each and everything that we need to do, because that's the way Brazilian financial market is structured right now. And so, let's go a bit deeper into what core is, with the 4 APIs, with the data repository, which have some replicas of databases. We'll go deeper into details into this. We have broken the investments part of the platform into four micro domains, let's call it them that. A managed portfolios one, which controls everything about your investments, and investment service also, and withdrawal service, and a banking service. We have more of those, but let's focus on the more important ones for today. We have a processing service that works with queues. Basically, we have queues, the processing service goes there, reads from this queue, and makes some processing happen. And for the external systems, we have one that's really important, which is Sinacor over there. It is the national system for brokers, Sistema Nacional de Corretoras, actually in Portuguese, which is basically every single broker in Brazil have to report to this system, and it's a huge Oracle database basically. So we put the data there, call some procedures, and everything happens. We don't know how, but they have a pretty great system there to make sure everything is accounted for. So when we think about this sort of architecture, we need to worry about performance. And I have one simple question for you. What is performance for you? We have to be aware when we talk about performance of how our systems work and which kind of performance are we talking about. Are we talking about time, low memory, low CPU, cost, accuracy of data, consistency? I could go for various words right there representing performance, and most of them are related, but we can't have all. We can't do magic and make sure we have one single process that runs in 1 second and uses no memory or uses no CPU to process anything. So we need to think about these kinds of things when we are building a software that needs to scale, it needs to perform in several different ways and be fast at all costs. So, when we consider web APIs, we have time as a critical point, because we have one single request, we have a customer waiting in the end, and he needs to receive this answer as fast as possible. When we talk about processing services, we have also the timing issue, but we have several processes running, we have a concurrent, they are concurrent, they run in parallel, they have a ton of things. So when we talk about this time world and this time world, we are having two different time scales right there. For a web API, we cannot accept and take it as fast if we take 5 seconds to return an answer. But for the processing services, 5 seconds is it's incredibly fast. 5 minutes might be fast in some cases. So we need to worry about these kinds of scales as well. Let's start with one single request here to understand what is being done behind the scenes. The Portfolios API, which handles 92% of the requests that Warren receives, and 90.5% of them are reads. Keep this number in mind, it will become very important in the future. So, this is the portfolios, these are the requests. We go through an API gateway. This API gateway, written in Node.js, has a MongoDB. It will go to MongoDB if it needs some information from that. Not necessarily will go. It will be injecting with dry.se, depends injection and all that kind of stuff into the portfolios API to call the domain, go through the business rules, and go to the repository, which we'll call an Aurora DB. Amazon Aurora MySQL database, which is what we use now. We will go also into details about this choice. And this database is accessed through Entity Framework Core at this point and other architectures that we use as well. So we have them to be fast, to use not a lot of memory and not a lot of CPU. We cannot have a web API that does a lot of processing. We cannot have that. And how do we comprise to make sure this happens could be by using IIS. IIS, for those of you not from the .NET world, stands for Internet Information Services. It is the Apache from Microsoft, basically, the server. It has a lot of overhead. It has a configuration that can be a nightmare. It uses 3 times the memory that could be used with some other form of services, of web APIs. And it's kind of Windows bound. Kind of, because it actually works in Linux, but, well, you shouldn't do this. So we went in a different way. We started using self-hosted services. These services have low memory. They are easier to Dockerize, use Docker into them. They are scalable. We just open a port into a machine and run the service, and it starts actually receiving the requests. And they are not necessarily Windows bound. They could run in other kinds of operational systems. So let's talk about a little bit about the processing services part of the deal. We have several services several domains that runs services. Portfolios, manage portfolios, investments, withdrawals, and things like that, and they all access the same database. Only now, we are not talking about only using Entity Framework Core. We are talking about the use of Dapper and the use of DB procedures as well. We have several priority queues over there, high, low, and a default one that will handle every other process that are not scheduled as high or low. And why do we need to have these priority queues? Because we deal with a very regulated type of business, because the investments in some products needs to be done by midday, the others by 2 in the afternoon. So we need to make sure that this process run and have priority over anything that may be running at the service at that point. We need to make sure this happens and that the customer receives its withdrawal and has its money invested. A little bit about the processing services. They are fast. They need to be fast. They use a lot of memory. They bring some data that are immutable and needed to the processes to the memory to make sure we have a fast access. We use a lot of CPU because we need to process a lot of things, and we have the priority queues to handle all of this. And when we bring the 2 of those together, especially when we have one single data repository being accessed by them, we are making sure that we don't have chaos. Why do we do this? We cannot have one single database being written and also being read from at the same time, because we will delay the processes and we will also delay the ultimate customer experience, which is the main thing that we should focus on. We shouldn't allow the request to access directly the right database, because it will be being written. It could have some consistency issues as well. And how do we do this? Amazon Aurora has a concept of replicas. These are read-only replicas. So if 90%, 90.5% of our requests are from just to read, just when the customer opens the app and wants to know his rentability, his history, his chart, so he needs to go to one of these replicas because the data was already processed and is there to be just read. We have our requests, and the requests, they can answer faster because we we can have up to 15 replicas of our database, making sure that everything runs smoothly. And at the same time, the processes are writing in the main database, the master database. They are putting data there and are preparing it, and Amazon actually controls every single thing from the moment we write into the into the right database to make sure that every replica is up to date. This is in milliseconds kind of thing. So I think that answers a lot of why we are using Amazon Aurora MySQL. We have auto-scaling, we have replication, we have availability, resilience. We also have recovering. Thankfully, we never actually use it, but they can recover something if something goes terribly wrong. Amazon promises that we can recover. So we need to, I don't want to find out if this is true, but okay. But where did we lose in this approach? Where did we lose when we tried to tackle performance by using Amazon Aurora? Basically, we are talking about a .NET platform. Entity Framework Core, it's Microsoft's ORM, Object-Relational Mapper. So they should run together. This is something basic. Microsoft knows SQL Server, Microsoft knows Entity Framework. They obviously will create a provider to make sure things run smoothly. That's not, the same cannot be said for MySQL because it doesn't know, and the provider has a lot of issues actually. It's not as fast, the queries that it generates are not the best. So we need to run with these issues and make sure we find a way to deal with them. The solution then that we found, well, it's more of a sideways move. Actually, we are actually taking it into our own hands. We are using Dapper, which is a micro ORM. It does a little bit of the stuff that Entity Framework Core does, but it is a lot faster. We also use at some very low level DB procedures to make sure everything runs fast. So when we make this move, let's talk a bit about code maintenance. Well, we have this sort of code in C# here. It is Entity Framework basically doing everything for us. It will get a customer from its ID, and that's it. We are everything is controlled inside the IDE. We have, if we change a variable, if we change a column, everything is tracked. And that's not exactly true when we talk about Dapper, that it is. What would happen if I change the name of a table? If I decide that ID in the customer's table is not anymore ID. I want to call it customer ID for some shitty reason, I don't know. We'd have to actually get every single string that we find in our project to make sure they all run correctly, to make sure that we won't be breaking any sort of query in our production environment or development environment or whatever environment we are talking about. And one action that we actually took to make sure this happens is every single Dapper query have to have its own integration test. It's just something that will ensure that the query is actually running and it's not breaking anything. And when we talk about DB procedures, we want our application to be as database agnostic as possible. Let's say we use something very specific to MySQL, to Aurora DB, and wants to change it to use, go back and use SQL Server, or maybe start using Postgre or Oracle or whatever database that we'd like to use. We need to change this DB procedure. We need to keep track of this DB procedure. It is a pain, actually, that we are trying to avoid at, I'm not going to say at all costs, but we have to be very careful when we deal with DB procedures. So, to summarize, Entity Framework Core, what do we gain from it? It is strongly typed, it has tracking devices, and this is not just about code. Entity Framework also keeps track in memory of everything. When, for example, you go back, go to the database and get some data, Entity Framework keeps this information inside its own memory, and when you update it, it keeps track of all the changes that happen there. So it's very, very nice to work with, especially for CRUD systems. So we need to be careful when we start not to using this kind of systems. When we talk about Dapper, we have queries that are developer generated. It's not typed, it has no business rules actually, but that's just one thing that we need to be careful of as well. The code is not so easily tracked, but a lot more than when we talk about DB procedures. They are not typed, they are also developer generated. They are somewhat hard to track changes. When we do something in the procedure, we'd have to create a migration or something just to make sure the procedure is running with the latest possible version. We need to make sure that our GitHub or whatever system we use keeps track of these changes, the changes that happen to the code itself of the DB procedure. And it may have business rules, it allows for that, and we need to be, again, careful with the use of them. And how to dose it? We found out that we need to dose the use of this tree to make sure we have a maintainable code, while at the same time we have a code that runs fast, runs smoothly, has consistency, and everything works perfectly with these three approaches to database access, basically. In Entity Framework Core, we use it for migration control, for some basic CRUD, basically inside our intranet system, and also queries that are non-time consuming. We may use Entity Framework for Web API request, but only if the customer won't access it very often, not for portfolios for sure. Dapper. We can use it for specially created queries, some data transfer object that we want to bring from the database, some query very, very specific that we need to keep track of the time. We need to make sure that we are delivering as fast as possible, and queries that run very recurrently needs to use Dapper as well in our architecture. And when we talk about DB procedures, yeah, we are avoiding them. We have two DB procedures at this point, and they both do simple data transformation. They simply look at one data, make sure we check this data, and just copy for some other table inside the database. And what about the results that we got from this experience for this dosage? Well, when we have a complex query, at the point we were using another version of Entity Framework, actually Entity Framework 6, and it ran in around 13 seconds. It was a query in portfolios, so it was very heavily accessed. So a nightmare. When we start to scale, we saw this and it was a nightmare. We need to act fast to make sure things were running faster and smoother than before. So we went from Dapper, but our architecture had kind of a flaw over there because we were still loading Entity Framework's DB context. What this means, loading DB context. The DB context will bring a lot of things to memory that don't need to be there for this specific query. So we were actually able to go to around 1.5 seconds, but that's not the best we can do. And we went with only Dapper, a repository that only works with Dapper, doesn't do anything with Entity Framework, doesn't even bring it to memory because you won't use it. And we went to around zero point 0.4 seconds for this specific query. 32.5 times faster by using this sort of approach. It is a lot, and it's something that we may need to improve at some point. I cannot come here and say that everything is ready and never will be improved because I'd be wrong. Just to understand what happened there is that we actually took this request, removed entity framework dependence, and also took the matter of injecting the dependencies into our own hands. We didn't allow dry IOC, which is the dependency injection system that we use, to actually inject entity framework there anymore. And when we talk about a complex process, we'll see that we are talking about very different domains of time. We are talking about a process that runs every single day at midnight, every single business day at midnight, and it at some point it took 6 hours to run. This is huge. We cannot allow this to work. We need to make sure this runs faster. So we have a system that does a lot of external API access, has had no parallelism, and used EF core. So we changed this to access external API by batch. We added some parallelism to it and used Dapper to make sure we got to around 1.5 hours. So not good, but a lot better actually. And we actually were able, this API access, we were actually able to access its database. So we are no longer accessing an API, a SOAP API actually, so it's, well, SOAP is not gonna badmouth anything, but yeah, it's bad. We are talking about parallelism, we are talking about the use of Dapper, and we are making sure that the process runs in around 8 minutes at this point in time. 45 times faster, this is a lot, this is a huge performance increase for the process that we're talking about. So, we came to the realization that performance is essential. We need to make sure everything runs fast and uses as little memory and as little CPU as possible. Not exactly, but we need to make sure that these 3 points of the pyramid, they are running together and we don't overload the use of CPU or overload the use of memory just to make things faster. How do we scale then? We have one thing that people have been talking a lot about, which is the monolith. We are not at the monolith anymore. We were able to make sure we have something called microliths at this point. This is not a term of mine, it's actually out there. So we are halfway through the path towards microservices. Microservices, what's the big difference between microliths and microservices? Microliths all access the same database, and microservices, each and every one of them has its own database. So, what are microliths then? We have independent APIs, we have independent domains, we have database replication to make sure that the APIs doesn't affect the processes and vice versa. We have processes that uses a lot of memory. They have in-memory processes. We bring, for example, information from products, information from everything that happened in the market, bring it to memory because that won't change immediately at least. And we use this information that is in memory to make sure that the processes runs faster and everything is processed accordingly. We also have priority queues, and these priority queues are used to control which kind of process we need uh, to process faster, to make sure that one process doesn't go over another one, and that it becomes chaotic. So there are microliths, just to make sure everyone understands what microliths are. Portfolios are a microlith. Managed portfolios are another microlith. Investments, withdrawals, banking, accounts, everything can be treated as a microlith. We have a domain-oriented architecture, and these domains or microdomains are the microliths that we are talking about. So, to summarize, we need to make sure that everything is a continuous work in progress. Nothing is ready. We don't have definitive answers. We are just trying to make sure that everything runs at the best way possible with the technologies at our disposal. Nothing is so good that cannot be improved. This is a lesson actually for life, a bit of a bumper sticker, but that's okay. So we need to worry a little bit about this as well. Thank you very much. And questions can be addressed at the lunch. I know you are all hungry. I am. Thank you very much.